Good morning, students. In previous class, we have discussed what is interrupt controller and what is interrupts and how it is connected with the processor and its specification and its pin diagram in detail. Today, we have to see about the block diagram of 8259 of PIC. So, the block diagram of 8259 consists of 8 blocks. One is data buffer, data bus buffer. Second one is your read and write logic, and third one is your cascade buffer comparator, and fourth one is your control logic, and next one is priority resolver, and 3 register, that is ISR, IRR and IMR. So here the data bus buffer, this block is used as a mediator between 8259 and 8085 or 8086 processor by acting as a buffer. It takes a control of take the control word from 8085 microprocessor and transfer it to the control logic of 8259 microprocessor. After selecting of interrupt by 8259, based on the priority of the interrupt, it transfers the output of a selected input and addresses the interrupt service routine to the other connected microprocessor. Next is your data bus buffer. Consists of 8 bits represented from D0 to D7, which we see in the pin diagram, and this shows the maximum of 8 bits of data can be transferred at a time. And next is your read and write logic. So these blocks represent when the value of CS is low, and it is also responsible for the flow of data depending upon the input of read and write. These two pins are active low pins used for read and write operation. Okay, and next is your control logic. So it is a center of PIC and controls the function of each and every block of this architecture. And it has an INTR which is connected with the other microprocessor for taking interrupt request, and pin INT for giving the output. So 8259 is enabled, and the other microprocessor interrupt flag is high, then it causes the value of output of INT is high. So in this way the 8259 responds to the request made by the microprocessor. Okay, and next is your IRR. IRR is something that interrupt request register. It stores all the interrupt level which are requesting for interrupt services. Next is your ISR, is your interrupt service register. It stores the interrupt level which are currently being executed. Next is your interrupt mask register. So it stores the interrupt level which has to be masked by storing the masking bit of interrupt level. Next is your priority resolver. Priority resolver examines all the 3 registers, and it sets the priority of the interrupts according to the priority of interrupts. The interrupts with highest priority is set to ISR, and also it resets the interrupt level which is already being serviced by IR. Next is your cascade buffer. So cascade buffer is to increase the interrupt handling capability, so we can further cascade more number of pins by using cascade buffer. So during the increment of interrupt capability, the CA line is to be in control. Next is your slave program and enable buffer pin, which set to high works in master mode, else in slave mode. In non-buffered mode, whereas your slave and enable programs is used to specify whether 8259 works as a master slave or a buffer. So this is the main block diagram of your 8259. So the highlighted one is your internal data bus. Okay, and here these signals are used to communicate with the 8286 microprocessor, and CS is your chip selects, and this is highlighted one is your subsystem handle all external interrupt request, and this is your IRR and the interrupt request register, and next is your interrupt service registers, and these details have been explained up here. And the last one is your highlighted one is your interrupt mask register, and this is your cascade buffer. So this is the overall diagram of cascade buffer, and this 8259 is acts as a master, and it also acts as a slave. Okay, and these are the pin configuration of master and slave concept of 8259, how it is connected with each other for communicating purposes. So the programming of 8259 accepts 2 types of command words generated by the CPU. One is your initializing command word and second one is your operating command words. Before normal operation has been begin, the system must be brought to the starting point. So we use this initializing command word. Operating command word is that it needs to operate at various interrupt modes, that is fully nested mode, rotating priority mode, special mask mode and hold mode. Okay, and these are the pins which we are using for programming of 8259. And here this selects the vector number used for an interrupt request input. For example, if we desire to program an 8259 so that it function a vector location of 082 0FH, and next it is used only when IC W1 indicates the system is operated in a cascade mode. And for example, if we need a slave to IR2, then we need to program IC W3 for this connection in both master and slave. Suppose we have two slaves connected to the master, then we have to program the master. Okay, and it is programmed for the use of 8086 or 8084 or 8088. This ICW is not programmed in the system that functions in the 8085 microprocessor. So this is our operating command words. It is used to set and reset the interrupt mask register. When the mask bit is set, it will be turned off for the corresponding interrupt input, and this mask register is read OCW1 read. And the next one is your it is programmable when A01 mode is not selected. Okay, this is the detailed operation of your interrupt service. Okay, I hope that you all clear about this programmable interface connector of controller of 8259. Thank you. If you have any clarification, please feel free to contact me. Thank you.